And we are live streaming now. So feel free to get started.
Thank you, Christina. Hi, everyone. I hope more people I hear are registered. I hope people will join as we start. And this is one of the sessions in this meetup. We'll talk through one of the very new projects in the uh, LFTT Labs ecosystem called Decentralized Directory Protocol. And we'll go through the more of a story and both the architecture. It is designed for mostly the what do you say the common people to understand why we needed it, and then we will go through technical and we will spend a lot of time. We have reserved a lot of time for question and answers so that we are happy to discuss, answer, and learn from each of you in this platform. Let me start sharing my screen so that we can get started. Just a minute. Okay. So what you see on the screen is actually about the decentralized directory protocol. Idea is to provide seamless access to public data with trust. While we are focusing a lot on public data, it is about any data, to be honest. And we'll talk through, my session, the first part of the meetup today will be about the story behind it, why we thought of it, what was the need, what was the thought process behind, and things like that. And the overall project is sort of sponsored, visualized by NFH, which is Network for Humanity, which is also a parent org for Internet Labs and also Beacon Protocol, one of the largest DPIs running in India. And we have part of LF Decentralized Trust as a foundation, and DeWi is also part of it, both in the design discussions, and also we are working on the first part of the implementation. So while the things are open, it's a protocol. We are happy to talk through how it can be used, how anybody can participate, and everybody can use the overall architecture and the platform. Just to start, so I just want to start with mentioning about the people involved. This gives some context because the idea is we wanted to highlight the experience of the people, what they had seen over the industry, and what was the learning. And that led to the foundation of the uh, DD or DD protocol, right? So the first one I want to mention is Dr. Pramod Verma, who has been phenomenal or foundational in multiple country scale projects, which scale to billions of people, like Aadhaar, UPI, GSTs, and currently he's part of NFH and part of Internet and FIDE. So he has been part of this. And Satish, who's CEO of the Way, head tech committee, MOSIP, which is another project which is part of building the foundational identity at a country scale with the biometrics and stuff. And Amar Tumballi, that is me, I'm CTO DeWi, and Nitin Mishra is the ex-CTO of ONDC. When he was participating, he was part of ONDC, and he's also ex-GST member, which is also tax collection and overall infrastructure behind, right? And Siddharth, who is also CEO of Internet, Surendra was part of DeWi, and there are so many more people. This Sankashan is part of the call, Mudit is talking now, Adi, Anu, Bashi, Shashi, and many more people. So while we started discussions on DeDi as a requirement because we started discussing on Internet or implementing some of the solutions in India across the cross border and stuff like that. The whole thing was about what is that we need to fix or make complete digital ecosystem, right? So we already were using verifiable credentials, we were using DIDs, we had ecosystem or the digital platforms where data was available on a API. So why one more thing? So that was the whole question here. And that is where I just wanted to start the story, right? So first thing, uh, if you look at data today, so if I ask integrity, is the document untampered? Yes, it can be solved by verifiable credential, digital signatures, or PDFs, and many things. But is the document still valid? That is another piece where it is not completely solved. There are revocation registries, there are many solutions, but still not a very, what do you say? Excuse me for the noise. I have to pretty much off today, or rather Starbucks and work today because of some of the travel I have to do. So the validity is the next part of it. So validity, it is not completely possible with every digital translations because not every data is up to date. The other part is the source trustworthy? So that has been a question which is a major piece which is everybody is trying to solve now. So we'll talk through how DD was visualized. Okay. So if you see the picture now on your screen, the use case is very simple. This is what we were trying to solve, right? If somebody has to hire an employee with previous experience, how do that works today, right? So it can be same for somebody student applying for a university across the like border, or if you're hiring a house help where you don't have a lot of history behind and things like that. So normally, what is happening today is either we do background verifications because there are background verification companies, or there are things which are most of like public keys or digitally signed. Then we depend on a DocuSign like a private player to give it, or a DID or a public key posted in a website, or somebody checks their website and gives all this data. And it's a tedious process, and at the end of it, we are still not 100% sure whether all of this is managed right properly. So, and are we guaranteed if employee what he's saying is true? Not absolutely. So that is the problem we were trying to solve with DD protocol. Let's look into again the same thing. The problems, if you look into this, uh, the challenges when we looked into it. The data was mostly manual, especially in India. In geographies, it may differ. Some of the places it may be already digitized and available on APIs, which is also true in certain domains in India itself. Like financial domain, we can actually verify a bank is banks by its probability and things like that. But and APIs are available to something called as a DigiLocker we have here, which is like many countries have their own passport, digital passports, or multiple API services from many departments. So but it is still manual because some of these portals have data in a HTML format. Some of them have it as a PDF file. Some of them have as a CSV file, maybe you have to download. Some of them have it only visible on a UI, not crawlable, so it is not API friendly, things like that, right? And APIs, each of them differ. So which means every client or application which is using the API will have to implement their own specific custom route for different countries, different geographies, different departments, and stuff like that, which leads to, of course, a lot of higher cost. And if some API changes in the place, we won't know directly. So, and because none of this is completely available in a digital way, all of this can actually lead to delayed or outdated information, causing even a compliance issues for many companies. So which has a chance of losing business, right? So it is all causing to missed economic opportunities. And as part of it, of course, the slide is ready to NFH. Now, our idea was, okay, all of this is a real thing. So, and everybody knows it. What are the few things or low hanging fruits to solve? So in a 80-20 rule, right? So what can we do in a 20% which can solve 80% of the problem? And that is what we wanted. Rather, I would say, what can we do in 20% which can solve, say, 90-95% of the problem? That is where large impact we are looking at. And what we wanted to make sure was we don't want to fix everything which is broken because it will take a longer cycle. We wanted to see What is already working, keep them. What is broken, specifically in a flow of maybe an example of hiring an employee, focus on only fixing those pieces which are like missing. And that is where we head into registries, because end of the day, the data, if you look into it, which needs to be verified or validated against and things like that, are always managed by some or the other uh, entities. Entities, it can be government, departments, companies, and things like that. So we call them registries, right? So first part is, if you look into what is broken, today, if you have a website, it is not 100% guarantee it is authentic proof, because website is managed by somebody in marketing team. You don't have history of it. Somebody can change it over the day. And whether URL belongs to the same company, you are not sure. Sometimes a lot of spoofing happens because one looks like I or IL or things like that, and a lot of issues there, right? So it is not guaranteed of authenticity. Second is, databases doesn't have history of all the changes. They will have latest data, but you have to implement all the standards, compliances external to the software. It is a process which will have to bring that. Then PDFs and CSVs, it is a real time, like they don't give the real time update because they are mostly static in nature. So those are the challenges. Then we actually categorize registries into uh, more of four generations. So generation one we called as manual, which is like either a PDF or a written statement which is put on a board in a office or something. And second one was a portal, which is like more of a website, or you can query. You can go there, query, giving captchas and things like that. It needs a person in middle to verify them. Then check the APIs, like they are generation three because they have the proper APIs to query. But again, as I was talking, they are not enough because they are not interoperable, they are not standardized, and they are not, they are mostly centralized because API has to be served by somebody, right? And that's where we call decentralized directories as a generation four. Um, so let's look into what was the trusted part today, right? So if you look into the trusted parts, three things comes into mind. One is the domain name itself, because if you look into any service today, your verification starts with domain name verification. For example, if you want to host a website through, say, AWS, your ownership is about putting a text records in a domain, and then comes, okay, you can host a website. Your GitHub ID, your DIDs also have a reference to your domain. So your domain name is where it is printed in a sheet saying, okay, you go here to verify, things like that. So domain name is mostly there as a trusted part. Like if I say, oh, it's a government service, a lot of people believe ending some service ending with a .gov as a valid government source, right? Because it is owned by a government. And then .gov.in India and things like that. So that's how many domain name becomes a company ownership or even the entity ownership. And digital signatures, of course, it is being used across, right? Cryptographically signed. Of course, signature type can differ, but digital signatures with public key, private key combination is proof of ownership. You sign things, and that is a digitally provable, machine verifiable data. It is working. It is good. It has been working forever, right? From the GPG days, like 30, 40 years before. So it is still working, and it is a good. And APIs, of course, the REST APIs, applications work this way, make calls, and any application would be using the similar APIs in at least time to come, right? So those are the things we are, which are trusted, working. We want to keep it that way and build on top. So that's where most of the things you see in DD are related to these things. So now looking at decentralized directory, how it brings each of them together, right? So of course, every data packet is digitally signed. Normally, many things do it today, but why we are calling it specifically? So that historic data of who signed what, who did the operation is captured. It is available in the APIs so that you can verify it, right? Later. And then every transaction is expected to be immutable. I'm calling expected mainly because we are not mandating this. The API says, if you look into the specification, there is a query for every lookup which can say as on, or give me the content of the registry as on this date, or content of this particular entry as on this. So that way we can actually show even the historic something which is entity which is there today, but like not there today, but was existing say, few years before. So that entry may also be verified, right? So that is the idea for keeping this thing uh, like immutable part of it and build a build a trace for every transactions, right? So then that allows also history to be there, right? Then all of this is accessed through API so that it becomes very friendly. And we have structured every registry under a namespace. So normally a namespace is visualized as tied to a domain. So you can, if you know one domain, so then you can actually verify the registries. Like think of it as, oh, if you are going to like from India, if I'm going to US, then if I know US banking sector is controlled by some US government, some site, some domain, all I need is to trust that and start from the registry there, right? So that is how the whole root of trust would work in this case. And that's what we are trying to build all of them together. And of course, why name decentralized and name DD itself, right? So while thinking of it, so what we realized is uh, decentralized has caught up. DeFi or decentralized finance was a word which has become very normal. Similarly, we were thinking of this is a decentralized concept because everybody owns their data in a way that not about where they host, but about they have to sign and manage the data. So hence, it is very important to note the ownership is still with the entity which is managing the data. Hence, it is called decentralized. And directory, we wanted to mention it is like a your yellow pages or things like that. We used to call it telephone directory and things like that, which is public in nature. So that is a differentiation we are making here, especially when we call decentralized directory. Our idea is focus on data which is public in nature because there are so many registries which are maybe private to an entity, private to individuals, private to a partnership and things like that, or even private to governments or between India, between governments. So hence we are not focusing on every data in the what do you say spec and the standard because you can ask, oh, why not about private? It can be used, but we as a standard making or consuming body, we are focused on public registries, right? So that's where we called it directly. And with that, the name DeDi came through, and that's idea. And with all this, so the idea is to make the whole jumbled flow into very seamless, simple enabler through APIs. It may be a for loop which will check employee to employee to employee depending on your submission. So think of it as if you are aware of verifiable credentials ecosystem. If somebody presents a verifiable presentation, it will go through every credential in the presentation and still verify all of this, saying the question was, is the issuer valid issuer, right? So that was the question which we wanted to answer. And that is the part where DD comes in here. And the idea is there will be always a registry, one from say ministry and another from previous employer, all of this, and another one which is keeping revocation list. So all of this can be checked using DD. So that way you are very clear for validating certain employments. These are the registries I am checking. So the which registry you check is always dependent on the employer, right? So employer or the application which is checked by employer can always make sure it is it's a valid checks. And yeah, that's the idea, vision, right? So make it seamless, make it verifiable with guarantee, which means even verification can get signed and everybody on the registry managing side can know, oh, this guy is verified. So that is an option again, because sometimes anonymous verification may be a requirement. Sometimes it is a choice if a government wants to provide or entity wants to provide it. And coming to it, our idea is focus on today's need because we have to solve it anyway. And tomorrow we always believe if you solve a problem today, the demand increases tomorrow. So always design for that also. So that was the vision we started all of this. And the idea is this has to be a universal protocol. When I say universal, it has a standard public protocol definitions available. So idea is any registry and anybody can access it. So with concepts, right? And then it is all machine readable and machine verifiable. So that's the main part. And provenance is part of it because every data is signed by the private keys and while creating the registries. And it also supports coexistence of multiple data standards. Like idea is it is one's output part because we are talking only about the access here. So it can also support some other formats. The same database can give the data out in some other standard and it doesn't stop that from happening. So and the idea is it is more of uh, built with more concept of memberships, public keys, and revocation as a focus. So that's mostly the part we wanted to talk about. And if you look at it, some of the organizations which are helping, of course, the DD protocol itself is hosted on LFTT Labs in a GitHub. So thanks to the team. And DD Global is a website. It is a SaaS offering from NFH based on the DD protocol, and it is like majorly visualized as a free universal DPI. So DPI is the concept which is helping in digital public infrastructure. Things like think of it as a road, which will help a lot of vehicles to move. Right. So this is the vision which DD Global from NFH has. So idea is anybody can get started. If they want to move their registry separate later, they can do that later. And DeFi is just enabler of this service. And we are providing the first part of it on Card Chain as a tokenization and a proof and the token things. That's what DeFi is coming into the picture here. And backend protocol is an early adopter, or I would say first adopter, at least in the discussion. The idea is backend protocol is visualized as a commerce thing where a lot of what do you say registry check has to happen, whether he's a valid seller, whether somebody is a valid participant. All such registry check will have to happen because it is a decentralized network in a concept, right? So that is where we see AD will be very, very useful. And thanks to backend team, they are happy to adopt it first and they see immediate need. And Internet Labs, of course, would be majorly the consumer to start with. They will bring a lot of other things. So that's how we are visualizing and starting the project. Because to start a project, you always need uh, 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 consumer first and then adapter second. So all of this is set in place. So we are going ahead with a full force to get this as a pilot to production. So we are calling it as a production at national scale or pilot at a national scale to prove the thing. And yeah, that is it. And with that, I would like Mudit to take over and get started with your architecture part. And I will have all the time for you to ask questions at the end, or you can stop, or we can do the session. I believe it is good to go through the architecture first and then have the question and answer, but left to the people. Thank you.
Right. Thank you, Amar. Let me also present my screen. One request which I have for every one who's attending the webinar today is to feel free to stop me and ask me questions if that is required. Do not worry about me stopping me later or something like that. Stop me in between, okay? You're good to go. So I am tasked today to talk about the architecture of DD. Before I start, I will like to thank everyone who has joined us here today. I know you could have done something different, but you guys came here. Thank you so much. Thank you to the LFTT team to organize this. But I'm pretty sure about one thing, which is you spending time to learn about DD will not be a waste. It is a revolutionary protocol, period. It is good to always know about such new protocols, upcoming protocols, right? So let's quickly dive into it. I'll be talking about how we designed the protocol that enables anyone to build trust infrastructure services. And throughout my presentation, my reference point will be our first implementation of the protocol, which was, as Amar pointed out, which was by NFH and is called DD Global. So let's get into it. All right. The first, I hope, yeah. Before I dive into architecture and you start listening to me for a long time, it will be a good activity if all of us who are participating in the webinar can have a quick poll. So this poll is about, the question is, how many public registries does your organization rely on weekly? There are three options, whether it is 0 to 2, whether it is 2 to 10, or whether it is 10 plus. Please feel free to drop your options in the chat. It is not a mindless activity. We'll be joining this, we'll be connecting this to from a couple of slides ahead. So I'll wait for half a minute if someone wishes to drop it, then we'll take it up from there. Oh, 10 plus, we have a 10 plus. Thanks, David. We have 4. I'll also go ahead and say I'm somewhere around 5 or without knowing. Yeah, I think if someone else wants to drop it, all right, let us go ahead. Okay, what I mean about this, I will talk about it later. We'll come to it. So before we actually start talking about any solution or any architecture, in my understanding, it is always better if we understand the problem that it is trying to solve. The solution, any solution, is only as big as the problem that it is trying to solve. So I was looking up the internet, and what I saw was a couple of very fascinating numbers. All right, these numbers were so big that it will be difficult for all of us to actually wrap our heads around it to understand it. Think about it. India lost around 36,000 crores, which is around $4 billion in just bank frauds, which was in 24, which was a 3x increase from the last year. The the FTC data shows that Americans lost somewhere around $12.5 billion in 24, which was once again a 25% increase. UPI, which has gone worldwide now, Indians still lost around 1,000 crores, which is a lot of money, to UPI scams, which is also on an increase, which was double from the last year. The counterfeit medicine, for example, the worldwide counterfeit medicine is approximately 200 to 432 billion dollars big, which is difficult to even comprehend these numbers. But the question that comes up is, why is all of this even happening? What do we not have? The answer that I always come back to is these frauds happen mostly because of the fragmented and the outdated registry data that these organizations have to work with. Think about, if your application depends on some certain sources, what happens between those delayed updates that happen? Let's say the source registry creates a certain data, and the window between creation and synchronization between your application can be so big that most of the frauds can happen between that. DD was actually born out of a need to close this trust gap, or as a fellow co-worker of mine, Sankarshan, who's also here, says, he calls it proof gap in digital transactions. Outdated registries can cost billions of dollars and expose organizations to risk which they should not be exposed to. The question was, can trust be made programmable? Can it be made real time? Think of a world where you live, where compliance is done in real time and not 7 days after something has actually happened. So if we think about all of this, that is where you'll understand where DD is coming from. So once now we have quite a bit understanding of what the problem is, let's shift our focus to what the protocol is. So I'll talk through two diagrams. Okay, the first diagram that you see on your screen, is what I think all the applications today, whoever are interacting with any public registry or any data source, is doing. Let's say there are n different sources that the application is dependent on. N different sources means you have to work with n different API specifications. You need to work with n different formats. Think about what will happen if um, an API endpoint or the request of the response body changes overnight. Your application was working last night, the next morning it will stop working. Think about why is it so that the data source, whenever it updates something, you have to wait for a certain time and then take a pull from that data source, and only then you have the latest information or latest state of the data in your application. What if we could change this diagram to something like this? What if for all the what if every application needs to just talk to a single source? What if they have to just work with a single set of API specifications? They need to have they need to work with just a single format. What if they do not need to worry about constantly pulling the latest state of the data and synchronizing their own data with the sources that they are working on? What if the sources actually tell them that there is an update? You can look into it. This is where this one point is DD. DD enables all of it. DD is the answer to all of these questions. So before we move further, it is always good to understand what is the difference between the protocol and the implementation that we're talking about today. Protocol is the DD protocol, which is an open standard protocol under LFDT. But DT.global is our first implementation by NFH. So think of protocol like HTTP. It is open for everyone to use, but the way people create servers using that protocol is entirely different and is very dependent on their business use case. And that is how we want the implementations to be. We would love to have multiple implementations, multiple interoperable operators. That is our whole vision here. And throughout the presentation, we'll be going over DD's architecture using DD Global as a reference. So what are the, if we have a very high look at an eagle's view from top, what are the not even five, what are the layers that DD actually has inside of it? At the bottommost, there are 5 layers, okay? At the bottommost, there's the trust layer. What's the trust layer? Trust layer is is the way we cryptographically sign any transaction that is happening or any change, any creation, any updation that is happening in DD, and how we anchor that or maybe let's say how we hash the entire state and sign it and then store it on our in-house blockchain, which is called cord. That's the trust layer that brings the actual trust to all any transaction that DDs that happens on DD. On top of the trust layer sits the data layer. This is where every entity, right? What is entity? We'll be talking about it. Give me a couple of slides more. With the data that gets stored inside DD, it is stored in a very structured format inside the data layer. And this is also what enables the versioning of all the data, all the entities, also allows auditability. On top of these two sits the discovery layer. The discovery layer is very specific to DD Global right now. What we have enabled is every namespace can be verified once a domain is attached to it. So if a request is sent to a domain, it gets rerouted to its namespace. So think of you using a DNS service. You give it a domain name, it reroutes it to an IP address. Similarly here. On top of that sits the verification layer. Verification layer is quite tightly coupled with the trust layer, all right? So what if you can take up you can pick up some digital signature from the trust layer and can put it in the verification layer and can actually verify. It does not matter what time of the day it is. If you come to think about it, the current implementations, if you want to verify something from a centralized authority, you cannot do it 24/7. You need to do that in the organization's working hours. But as blockchain does not have that, blockchain is a decentralized technology. So verification happens 24/7. And on top of everything sits the DD APIs. They are really good. We'll be talking about them. Let's get into the trust layer. So the trust, if you break down how the trust is actually enabled, okay? Think of what does an entry here actually mean? Entry here will be, let's say, a creation transaction, an updation transaction. Let's say you're creating a registry, updating a record inside of it. You are changing the state of a record inside a registry. Any of those transactions, they can be called an entry in my case here in this slide. Any changes are always first hashed, and those hashes are then digitally signed. Hash is a SHA-256 hash, and digital signature is a ED25519 signature. And this signature is then anchored on the blockchain. Now, once something is anchored on the blockchain, it can be used later as a verification source. So now, if you for anyone who could have imagined this, okay, right now, if let's say there is one blockchain layer and there is whole another DD infrastructure on side of it, it can give us this kind of structure. If you see on your right, this is very interesting. I would like you to remember this structure for the rest of the presentation too. What will happen if there are multiple DD implementations all talking to a single chain? Think of the chain being deployed by a government and all its organizations, all its departments having their own DD implementations, and all of them are connected to the same chain. What this enables is that you can pick up a signature which got generated in one DD instance, and you could verify it. Let's say for all of these DD implementations, all you need is one verification system. You can pick up a digital signature from any implementation and put it there. If we extrapolate this once again to the government and all its organization, think how easy life will become for the citizens. But if you see on your right, there are two chains and there are multiple DD implementations connected to each chain. You cannot pick up a digital signature from one chain and put it to the other chain and expect it to get verified. That is not how it works, but that is also a different use case, and we'll come to that. And the blockchain we use, as we talked, it is developed and maintained by Thive. It's amazingly perfect for this, and we'll talk about why it is so. Two big things about DD is how the information is organized and how the states are changed for each. Now, we'll be talking more about in the terms of records and not in the terms of registry. There are state updates for registries too. But let's first talk about data model. If you remember a couple of slides back, I talked about entities. What are entities? Entities can be any one of these three things. NS stands here for a namespace. There's a registry, and then there's record. So think of namespace as the biggest segregation in DD, in the DD world. Mostly, a namespace will represent an organization. One namespace can have multiple registries inside of it. An organization can have multiple registries that they maintain. So the registry will be a more purpose-specific data set. Inside each registry will be multiple records, and this is the most granular part of DD. If you see here, I've also written versions. So what DD enables is versioning for every kind of entity, whether it does not matter which one of the three we are talking about. If you think, in current scenarios, the databases do not allow you to have a look at the older states of data. It only allows you to have a clear view inside the current state. So what if you made a business decision because the state of the data 10 months back from now was something, and it has been updated? What if someone questions that decision of yours? How will you go back and prove it? It is not possible using the current scenario, current implementations. But with DD, that is very much possible. As every updation of any entity creates a new version, that version can be used to look at the state of that entity at that time, maybe I'm using version 123, I can put it back and I can fetch the version as it used a version of, I can fetch the data, how it used to look like when I used it. Does not matter how many changes it has gone after that. This is a very powerful thing about DD. If you look at what state updations are allowed for the records, so any record that gets created will first always get created in the draft state. So when it is in the draft state, the record, any information about the record is not actually anchored on the chain. The purpose we did this was if you create an incorrect entry, incorrect record, let's say, and you do not want it to be anchored on chain, it is a very much possibility. When you want to make it live, when you want your users to use it, when you want people to view it, you'll have to change its state from draft to live, and that is called publishing the record. Once it is published, there are two states that it can further go to. One is it can be suspended, and one is it can be revoked. What are the difference between both of these? Going from live state to a suspended state is a two-way street. So you can you can change the state of the record to suspend, and you can reinstate back to live. But once it is once the state has been changed to revoked, there is no going back. So it is not useful. No one will be able to use that. So these things can also be extrapolated to real world examples where if you think about it, my driving license has been suspended because I am yet to pay a fine. But once I pay the fine, it will once again be reinstated. But if I'm a criminal, the government needs to blacklist my Aadhaar card. They will revoke it. They cannot suspend it. So after these four states, the last state is the expired state. So every record that gets created has a time to live, has a TTL. So it does not matter where, in which state the record is. If the TTL is reached, if the time has reached, it will just go to expired state. And this is also very much a real case scenario. Your driving license will get expired, let's say, after 20 years of when it was issued. So this is what the states look like for a record. If we talk about our implementation, I'll quickly take you through the technologies that got used here. For the API services, we use TypeScript and Node.js for quicker deployments, quicker APIs. For storing of all the structured information, we used Postgres. And for quicker retrievals, for caching, we definitely use Redis. And on the bottom of every DD implementation will always be CORD. We'll next look at why and how it works with CORD. But if you look at the transaction flow for DD Global, specifically for DD Global, what happens is you need to think of it from two directions. One is the publishing of the information, and one is the verification of the information. If you think about the publishing, okay, there's a set of APIs which are just to publish your namespace, your registry, your records. Once it is published, it will not directly get added to DD or a registry, let's say. What will happen in between is there's a validation engine. So let's say a registry defines a schema and it says that every record that gets added inside of it needs to follow a particular schema. So the validation engine will make sure that that actually happens. After that is done, it will then be stored inside the DB. Many things will be stored, anchored on the chain. So this is the publishing part. Now, if we look at the verification part, let's say the users use these two set of APIs. We'll be talking about APIs in great detail later, but these are the discovery APIs. Let's say the user wants to discover a record. What they will do is once they call this API, the response will be stored, will be cached for later quicker retrievals. And then you can use the response that you have gotten out. Then you can pick up the signatures and use it to verify what TD claims to be the real data. So this is the whole transaction flow. Now, if you look at the blockchain integration, we made a decision to not store the entire object or the entire entity on the chain itself. It would not have made sense. It would make the chain slow. It would have been a very expensive transaction. So what we did was we had off-chain data storage for performance. It made the system very scalable and it was also cost effective. That's true. But on the chain, we stored the cryptographic proofs, and all the anchoring was done on the chain for everything that is there in the DB. This gives DD the tamper evidence that it so likely boasts. If we come here in the transaction flow for how things happen in COD, let's say an entry gets created, it will get hashed. Many hashes will be put together to create one transaction because COD allows you to send multiple batches of information inside one transaction. I think it is 500 currently. So it will batch all of them, create a COD transaction and send it to the chain. And the proof of storage will be given back, and that will be stored in the DB for the user verification. So what are the APIs that DD currently exposes? There are more APIs than these. Let's say I have not covered the publish APIs here because I want to talk about how the data can be used by the applications. If I talk about the 5 different APIs, they will be the lookup API, the query, search, version, and watch. I've also added an example next to each of these types of APIs, which in the dialog box, read that too. So when do you use lookup? You use the lookup API when you know what exactly it is that you are looking for. For example, you want to look up a particular registry. You want to know when it was created. You want to know what is the current version of it. You will use registry lookup. It is the same for namespace lookup and also for record lookups. But what if you do not know what you're looking for? What if you want to just have everything inside a particular entity? What if you want to have all the registries inside a namespace or all the records inside a registry? In both of these cases, you will use namespace query. And in the second case, you will be using registry query. It will give you everything inside of it. Search API allows you to search records based on the schema. Think of this. Let's say you want to search an employee inside a company whose age is 38. The lookup APIs will not allow that. The query APIs will not allow that. The search API will allow that. You can use it as this is the key that I'm looking for. This is the value that I am looking for. It can return you multiple records if there are multiple matches. Then there are the version APIs. The version APIs are for all the 3 types of entities. As I said, every updation, every state change, every creation creates a new version. So the version APIs will give you back all the versions of a particular entity. And once you have that version, let's say you have a string, the version string, you can put it back to the version API, or let's say a lookup API, and then you can have and then you can look at how the entity looked during that version. It does not matter how many updations it has gone over after that, but you can still look at the previous state of the data. So the last thing is the watch APIs. The watch APIs are particularly very interesting. So watch APIs allows you to have real-time event streams in your application. Let's say you want to have constant updation or you want to get notified every time something gets changed inside a registry. You want to get notified every time something gets changed about a record. Watch APIs allow you to do that. If you relate it with my previous words, which were talk about real-time compliance, the banks can have real-time watch on their registries, whatever registries they are interested in. Let's say if they put a watch on a registry, they will get to know whenever the registry is updated, and also whenever a record inside it is added or updated. If they put a watch on a record, they will get to know every time that record gets updated. So these are the 5 data discovery APIs. If we talk about a subtopic of my talk today is also security model. So security in case of DD has been built inside the protocol itself. There are definitely more security implementations can be done by the DD protocol implementations. For example, DD Global can have their own further security measures. But what does the protocol guarantee? Protocol guarantee as we have been talking so far about, it guarantees cryptographic integrity as the base layer, the most basic layer of DD is the blockchain. So um, it allows tamper evident data to be stored. The registry cannot be updated without anyone getting known. And because this is the case, there is also the security feature of non-repudiation, which means that if you have made a transaction, you cannot go back. You in future, if you're ever asked whether you made that transaction or not, you can never say no because it was signed by your public key or your private key. It is, and because DD is based on blockchain, on CORD, and as CORD or blockchain is a decentralized technology, it is available 24/7. So if think about current cases where I think about the example that I gave, if you have a bank document you want to get verified at 2 a.m. in the night, it is not possible. But what if that there was a registry, the public registry that bank maintained? Things could be verified then. Also, this because we do not store the actual data on chain, we store it off chain. So there is also the privacy service factor that we have, because there are many cases where chain hacks have been chain hacks have come up. So that is not good. What are some more implementation security features that we added? We were able to add to the DD global implementation. We added API authentication, rate limiting, secure API key management. When I say secure, it is secure because the database does not store the API key, it only stores the hash of the API key. It is always only with the user. And because we use blockchain, we also have the audit trail preservation. So any change can always go back. So this is what I call it, the unbreakable DD shield. If we look at what are the deployments and deployment ways of DD that I could come up with, it was there are multiple. On one end of the spectrum, there's the public service, much like DD Global, which is already hosted, it is managed. Any user needs to simply get onboarded, and the onboarding process is also very simple. On the other end of the spectrum will be the private deployment, which are the self-hosted. For let's say an organization wants to have their own DD deployment, then they will go with a private deployment. They can have very strict policies that they want to implement in that DD implementation. It will be a very controlled environment. But somewhere between these two will be the hybrid network, where think of think of the diagram that I told you to remember from one of the earlier slides. What if there are multiple cross organization collaboration that is happening? In that case, a private or a public is not good. In that case, a hybrid network is always good. So if I bring this back to the first question that I asked you, so the answer will be, if your organization uses somewhere between 0 to 2 public registries, I think it's either a very strict check on the registries. Then you need to go with the public service. There's no need for you to go with the private deployment or a hybrid network too. But if you are using somewhere between 3 to 10, it mostly means that you do work with a lot of private registries on a daily basis. In that case, it is good to have a private deployment. But if you are more than 10, that means like you're all into public registries. In that case, it is good to have a hybrid network and also specialized implementation, which means it is a very use case specific and industry specific implementation. Like a DD implementation for supply chain will not have the same compliance check as compared to a DD implementation for, let's say, financial world. So that is why it is also more of a, it depends on what um, industry the DD is getting used for. Now, on the other hand, if we talk about the governance, in the case of DD protocol, all the decisions, all the governance will be taken by the LFTT community. We have a repository on GitHub all of the conversations will be done there. All the conversations can also be done on the Discord channel. But let's say the service per specific operations, those will be defined by the implementers. Those they will have individual implementation policies. But bottom line for any of this is that the trust decisions in the end will always be taken by the registry owner. Who to add, who to remove, who to suspend is always on the registry owner. So I will like to boast a little here about what challenges we have already solved here. This all have been covered throughout my talk here. Think about cross-border trust verification. As namespaces are tied to a domain, there is no problem of not having trust across borders. High frequency update propagation. We have all, as I talked about, if something gets updated and you are subscribed to something, as in you have put a watch on some entity, the update will be sent to you instantly. So that is why I've written here high frequency update propagation. DD also allows adding delegates to a registry, which was done in an effort to mimic the real world. Um, and because of this, it allows multi-signature authorization. So it allows easier collaborations. And we know that organizations will not be creating an individual entry one by one. What they'll be doing is they'll have a big CSV file or a big JSON file, which they will dump on DD. And there's a particular API which can handle creating multiple records, multiple registries at one go. We have all, but one thing which I I think Amar is also a good person to answer this. But one problem that I often see is the legacy system integration. The legacy systems currently do not, it's not necessary that they store data in machine readable fashion. They might store it in PDFs. So how do we bridge that gap between unstructured data and bringing it to DD in a very structured manner is something which is a challenge, which I think. But let's stop all the theory here, okay? Let's uh, after this slide, everything will be more of a discussion. If per se, if the people are open to it, let's imagine some use cases first, okay? With DD, it is very much possible that banks verify their documents. Let's say their national identities or any document provided by some customer in real time using DD registries. They can allow instant opening of accounts. They can instantly flag people who are linked to AML cases or CFT cases. That can be done instantly. What if every UPI transaction makes a DD call to a registry before the money is actually transferred to the recipient? What if there's a registry maintained by the stakeholders, which we call, let's say, a blacklisted UPI IDs where money should not be sent? They can have a check, and this will bring down the frauds a lot. What if every property transaction, a recent number that came around was 66% of all judicial cases, at least in India, are property related. What if all of the property transactions can be made into DD registries so that all of the checks can be done in real time? Think about all the cases that will get solved. Banks will benefit a lot from this. What if telecom companies check a DD fraudulent phone number registry before they actually connect to people? All the potential uh, mobile scams can get reduced. So as we wrap up our protocol discussion, the next step is logically what are the next steps for the development of DD as a protocol and also implementations, and some of your questions, picking up some of your questions from here. One thing is, it would be very, it would not do justice to DD if all of you think that it is specifically made for developers. It is made for, let's say you are an architect, all right? You are developing some service. You want an interoperable trust infrastructure where you need not connect your application with multiple different service providers. All you need to connect it with this one service provider. Let's say you are a product lead. When you might want very faster launches, lower integration costs, DD allows that. What if you are a fellow regulator? Uh, for regulators, it's particularly interesting. It says DD allows real-time compliance. It also allows auditability. So it does not matter who you are, what your role is, DD has something to provide to all of you. So we talked about the current protocol version. What are some future protocol developments that we would like to have? This section is very open to discussion. It is open to discussion with the DD community. Um, some things which we would like to achieve is much faster APIs. Think of like APIs at the scale, at the speed of UPI transactions. If I gave that example earlier, what would it actually take to create such quick APIs? We want to get better query capabilities for the user to have much more granular control on what they are looking for, what they actually get back. What if we, what if, think about what if we create a registry which is populated by DIDs for each one of us who are present here? What if we own those DIDs and if we add ZKP to the DD protocol, it would be really cool. It would be cool to have ownership of a DID and show only particular fields out to someone. If we see what are some contribution areas for all of my developer audience, there are many. We would love to have some work on the SDK development. We would love to have some work on middleware, the tooling provider. There are too much to work here. We would love to have some collaboration here. One important slide is also this, all right? How can DD help in compliance checks? But DD does not say how the data should look like. And because it does not say that, it can have in each different implementation based on what they actually want. We can have like for example, the data that is actually getting stored inside a registry can be GDPR or let's say DPDP compliant. We can have cross-border data transfer protocols. So if a company is sitting in one country wants to do a cross-border check, they can do that. They want an audit trail, that is very much possible. And if they have a very specific regulatory reporting section, that can also be done. I think there's someone with a question, which is Michael. Yes, Michael. I'd love to hear you.
You may have covered this already, but I think it's an important point. So suppose I want to put a PDF, your early example, in the directory and have it verifiable via the blockchain. What's the chain of trust? Because I could just put anything on the blockchain, but why should people trust me, I guess, is my question.
Yeah.
Is there a chain of trust in the architecture?
I think, Michael, it comes back to if you have a namespace and if it is connected to a domain, and if the trust that is getting developed here at the first place is the domain that the namespace is connected to. Let's say if you have a namespace which is connected to a domain owned by the government of India, if it is verified, you can only have that if you're a part of the government of India. So if you put some information inside that registry, inside that namespace, I can stay assured that you are actually who you say you are. But I think Amar, go ahead, pick this up.
Yeah, so I think a couple of points here, right? So the chain of trust is the DD protocol itself says, or rather, what we visualized is the verification. Trust is always a factor of relying party, which means who is verifying, because it may differ from country to country, geographies to geography, based on which data you need to check for verification. For example, if I'm staying inside India, then a local Aadhaar, which is a national ID, is good enough. Whereas if I have to travel outside, the passport data, which is from a different ministry, different data is what will build the chain of trust. So in the context of that, why that is important is because who is putting the PDF in the proof or the registry here, right, is very important. So it can be you, but if you say you, the DD protocol says that is where the namespace is crucial because the relying party would be trusting namespace first, and that is working today because today most of the people go to website first to check, okay, it is a valid bank, valid entity, because the problem we are trying to solve is not the solutions where you already know the entity which is there. So if you are publishing some other entity, so the namespace is tied to a domain. So you have machine to verify. How do we know the domain? Because as a application developer or the relying party, you would know which registry to check already. So think of it if you are checking a social security number, right? So you know exactly which registry has social security number references. So similarly, that way you don't check 10 different registries. You always hit the same registry which has the social security where you will do the lookup. So the same story in different countries, different foundation IDs exist, different tax IDs exist, different driving or the license to work, license to drive, license to permission to establish business work. So every our vision, or when we looked into, that's where I said we are looking at something which is smaller fixes which will have a larger impact. So that is what it is, right? So it is similar. Like I think Daryl here was mentioning, right? So the trust registry, the concepts are similar, but our vision was on three things. One is membership registry. So that is what becomes a root of trust because you would be part of a organization or an entity where you are a member. So think of it. We took an example of a student going to a university outside the same outside the country, whichever country it is, right? So country A to country B, and the recommendation letter is given by a professor of a particular college. The college is part of a university. And how does all of this root of trust work? Like now I have to verify the student is valid, as in from that country, all of that. That record today exists because of passports and stuff. Now, student proposes a
Okay.
recommendation letter. Yeah, so it is the chain of things. And all of this starts with country B trusting country A's top level registry. So the professor will be member of a college. The college is a member of university, and the university is recorded in the country A's whatever educational departments. So that is the way it would look as a chain of trust. So that's the vision
Chain of
here.
trust.
Okay, thank you very much.
That's good. I think this almost brings an end to the presentation here. There are some links which have been added here. There's a link to the official LFDT repo for DD. There are also some Medium articles which I think someone looking to understand the DD APIs or how a world with DD capabilities would look like. All of this will be covered in these reading materials. And like something like the DD SDKs, we would much love collaboration here. This is something that is in the pipeline. This will be done for anyone a trying to implement DD in their own services. If you guys do not understand how the DD APIs work, feel free to reach out to any of us. It is me, there is Amar, there's Sankarshan. I've added the links to our these are our emails. Feel free to reach out to us. Um, one more thing is like, what will be the next action that people should take? Like, I would first recommend you, whoever is here interested in registries, to go out and try creating your first directory. We have use this link published dev.dd.global. You'll be able to create your own namespaces, registries populated with records, and then when you want to have a global view of what registries and what namespaces are available in that instance, you'll have to go, for example, in this case, like, at least you'll have to go to the explore dev.dd.global. Now, once you reach here, you'll have one hindrance, which I'll not say right now. I think if you reach here, you're already doing great. Reach out to us. We'll help you here. If you want to play around with the APIs, go out and use this. There's a sandbox which you can use, which is dev.dd.global. The entire material which I've mentioned here, which is the APIs explained. This one talks about all the APIs inside of it. That is a good place to start. If you're building some prototype, reach out to us with whatever questions you have, whatever errors you face. Join the DD channel in LFDT's Discord server for regular updates. We are all there. I think that wraps up my part too. I think there's one question in the chats which I've
Yeah.
not read. Amar, something.
Yeah, I will jump on it. For the
Yeah.
viewers, the question is there might be some conflict of regulations and requirements like it can be different from different geographies. And how does the cross-border data sharing work and how will it impact DD and can you give a use case and how the flow will work, right? So think of it as it is a very genuine question, and that is where I think we came from, right? Because with our experience with working on with regulators, what we realized is while like most of the technology world tries to focus on solving all this problem 100%, what we saw is regulators want to make sure their compliances are taken care of first. That is very, very key thing, right? So here, our vision was, see, any cross-border trust or the regulations or compliances works with country to country, normally signing MOUs, and they have their own way of declaring which is the most friendly country, which is the rules for each country, and that keeps changing. And that is the idea of this registry also, because, for example, if the rule changes today. So today it is all mostly published in a PDF, and many companies which depend on a cross-border doesn't update. And this is what I think Mudit was highlighting on the databases or the registries not getting updated results in the frauds and the loss of revenue, because many companies would not be aware of it or takes time to change all of this. If it is reflected in a API immediately, the signing happens. So think of the benefits. So that is the vision here, right? Now, coming back to data flow and other things, right? So that is where one thing we wanted to clarify as a hosting service is DD is a access protocol. It doesn't come with a compliance. Anybody can host it. Anybody can host their own data, right? In their own whatever capacity. It is about how do you access the data. There is a namespace, registry, and now, DD Global as our service, what we are visualizing is talking about public data. So idea here is when I say public, it is by normally gazetted means, as in if any country, each of the countries will have its own public data. So that data is what we are talking here. Hence, it comes under compliance naturally because it is public by nature or public by requirement. It is like, for example, any company will have to publish as in normally depending on the company's rules or country's legal systems, they will publish every entity which is legally operating in their country. So most of the companies have corporate affairs or the company rules for handling this, right? So this is where that registry, if it is visible, anybody else, any cross-border applications working with that country can verify that. Now, if a change happens, if the country says, okay, I don't want to provide it, the registry can be put on a stop and the country can revoke or archive that registry, which means the API will not be available. But what is the benefit of DD is a country or any service can't say that, oh, historically it was not there. The access may stop from, oh, say, today, like November 18, 2025, whereas as on, say, if somebody wants to query if on November 17th, the country, like this was there, the service provides it. So that is the idea behind having history being recorded, because when somebody published it, it was part of what do you say, the data thing. It was public, it was by nature, it was there. Now again, some places, as per the rule, they may say right to forget. It is part of GDPR, for example. And if an entity says, okay, I have to forget it, hence we have structured it in a way that it is a call depending on the entity where they are hosted. If they are legally expecting it to be deleted, that's where we are not putting all data on chain. Hence, it can be deleted, in which case it is a legal requirement. The lookups will say that as per the legal requirement, the entry or the top level query may say, okay, the data is not found or it was there, but not available for you to check because of the legal update. So that's where multiple status exist, multiple error message exist. And that's the vision we have. I think that's the idea. So uh, legal requirements comes at the top, but it is always the relying party who will have to depend on the particular registry, depending on their country's legal expertise. And in a world where even decentralized anonymous access is a requirement, you can check. It depends on which countries allow anonymous access to it. So that's where I think Mudit was highlighting on every registry having their own control of accesses. So that is the vision we have, because sometimes even though it is public, somebody may want to say, oh, I will only allow access if you log in. So I don't allow, say, every AI agent to build a database on it. Because today, in that case where it is even the public data, if it is given free, you may be like data is a new oil is a concept somewhere down the line it was there, right? So you may say, okay, I don't allow crawlers to come in. I will allow only logged in users to get the data. You can do that. So that is the vision we are also having. So it is, even though it is public data, the access, how it is to be given, can be controlled by the registry owners. That is the vision we have. Hence, we are calling it decentralized. Like DeDi as a infrastructure layer doesn't mandate many of these things. It allows the freedom for registry owners to control it. And registry access is always verifier's responsibility. That's what we call it. Like you should be knowing which registry you are checking for a particular identity. Because, for example, in India, Aadhaar number, which is a national identity, or even in US, social security number is a 9-digit thing, right? So nine, no, 10 digit, something like that. Yeah. So it is still strings or numbers, whereas it may be same with a credit card. It is also numbers. So it depends on which registry you are checking. If it is a registry of credit cards, you will be referring the number, and it will be getting. I mean, it is a check on a credit card data. Whereas if you are checking on social security number, it is a number. Similar in India, where Aadhaar number is a 12 digits, and you will check it. While I'm not saying Aadhaar will give us all the registry data publicly. That is a PII and other DPDP rules. That is what we want to adhere to. But the concept is similar. Relying party has to depend on which registry to check. We are allowing the service. SaaS service is allowing people to publish data in an easy way. The dependency or the success comes in making sure everybody follows the same protocol, so the applications don't have to bother in future or where I'm checking or it being changed overnight and things like that. That's the main highlight.
Yeah, I think it is also important to point out that every implementation can have their own compliance checks in place. So it is all a question about what the deployer wants to add to the DD implementation. I think that will bring us to. I think that will bring us in, bring us at the end of the presentation. I shall see. Yeah. Can you send on chat link to?
Okay, cool. Then if there are no questions, happy to keep discussing on the GitHub discussions. That would be a great place because it will have all the history. We can discuss in public. We prefer that way. And also the presentations which we had, I think will be shared with all the participants. Happy to answer any of them eventually. Uh, Thank you, and happy to see more participation, collaboration, because I think there is a requirement, right? So, and we know, being part of TOIP from long time and now being part of LFDD, there are multiple projects working on Trust, and it is not just DD, right? So we will be collaborating, and we are open to all of such things, so that ideally all these efforts coming together, we want to see the trusted world. That is what idea, trusted digital world, let me say, because in the physical world, trust is always subject matter of individuals. So we will make sure, yeah, all these collaborations happens, and it is just a baby step. We believe by bringing registries on API in a standard way, you will always end up having success. That is our at least current understanding. We want to keep learning from each of you from different geographies, and uh, build more things which will suit everybody's need, and hence more, what do you say, machine verifiable data, which is like oracles, we can say, right, available online. So that's the vision, and happy to work on this journey with all of you. Thank you. Thank you, everyone. I see.
Great.
Okay.
Thanks,
Cool.
everyone.
Yeah,
Thank you.
thanks everyone. See you in the next meet.